5, we're looking at quadratic equations here. Just remember with the null factor law, so if two things are multiplied together and the result 0, then either or both of those things are equal to 0. Alright, let's look at A here. I've got that bracket multiplied by this to give 0, so either x minus 5 equals 0 or x plus 6 is equal to 0. So I have solutions x equaling 5 or x equaling negative 6. For B, I've got 4x squared equals 25. I divide both sides by 4. I now take the square root of both sides, so x is going to equal plus or minus the square root of 25 on 4. Remember, when we're taking the square root of a fraction, it's equal to the square root of the numerator over the square root of the denominator. So the square root of 25 is 5, square root of 4 is 2, so it's plus or minus 5 on 2. For C, our first job is to take 14x from both sides, so I end up with 7x squared take 7x. 7x is a factor that I bring out, so it's now going to become 7x multiplied by x minus 1 equaling 0. So 7x equals 0, which produces x being equal to 0, or x minus 1 is equal to 0, which produces x equaling 1. Problem 2. We've got ourselves a triangle, and its height is 5 centimeters more than its base. So I do a little diagram to help me. Unknown base, let's call it x, and its height is 5 centimeters more than that, so let's write x plus 5. And we know that the area of the triangle is equal to 18 centimeters squared. Area of a triangle is half base times height. The area is 18, the base is x, and the height I'm referring to as being x plus 5. Multiplying everything by 2, expanding the right hand side, bringing 36 across, and now just finding the factors of negative 36. So the combination I'll come up with is negative 4 and 9, and you'll notice that when I add those together, the result is the middle term, 5x here. So you can do that using PSF or the grid method, whichever way you prefer, but you're able to factorise that fairly easily. So x equals 4 or x equals negative 9. Now this is impossible, x equaling negative 9. We can't have a negative amount here for the length or for the base of the triangle. So we're accepting x equaling 4. So the base is 4 centimeters, the height is x plus 5, so the height is 9 centimeters. Fair bit of maths involved with this problem 3. So the perimeter of a rectangular shed is 16 metres and the area is 15 metres squared. Use x and y to represent the sides of the shed. So I've drawn myself a shed and I've got x and y here. So writing the perimeter, P, the perimeter, is going to equal 2x plus 2y. So I've got 2 x's and I've got 2 y's. Adding those together, 16 metres. So that's my equation. B, write the area in terms of x and y. So the area is the length times the width. So the area equals x times y. So I end up with 15 equaling xy. Now that is all that is required for an answer for B. But what I've done here is just shown that y is going to equal 15 divided by x. I've just divided both sides by the x here. C, solve these equations to find the dimensions of the shed. So I'm going to start with the perimeter. So 16 equals 2 lots of x plus 2y. Now instead of writing the perimeter of the shed in terms of y, I'm going to write it in terms of x. What we found out from part B was that y was equal to 15 on x. So instead of writing this y, I'm going to write that it's equal to 15 on x. So now I have an equation with only one variable in it, x. So just multiplying the 2 through gives us that. And now if I multiply everything by x, I'll have 16x equals 2x squared plus 30. I will now take the 16x from both sides to form this quadratic trinomial. 2 is common to every term here, so the 2 comes out. I divide both sides by 2 to give us x squared minus 8x plus 15 equaling 0. I now factorise. So I want the factors of 15 so that when I add them together I get negative 8. And so they are negative 3 and negative 5. I'll write those down in the brackets. And you can see I have x equaling 3 or x equaling 5. So that is in fact the dimensions of the shed. It's a 3 by 5 metre shed. So let's pretend that x was equal to 3. If I did that, then y would end up being 5. And if I accepted x equaling 5, then the y value would be equal to 3. So either way you choose, you're still going to come up with a shed that is 3 by 5 metres. A little bit further with this problem 3, let's look at how we can use our CAS. And it's based on two main equations. I'm going to be using the perimeter equation, so 16 equals 2 lots of x plus 2y. And I'm going to be using the area equation, so 15 is equal to x times y. On my CAS, I'm going to go Menu, Algebra and Solve. I now want to bring in two equations, so I just hit the equation button and I want that option. How many equations? Just 2. And my first equation is 16 equals 2x plus 2y. And the second equation is 15 equals x times y. Now, the way that the CAS would see this xy, it would see it as being one variable. So I need to let it know that they are two separate variables, it's x and y, and they're multiplied together. So I need to put a multiplication symbol in between the two. It's not as important here because it's clear that it's the number 2 multiplied by the variable x, but essential when you've got variables multiplied together that you let the calculator know that it's a multiplication. It's not the one variable xy. I now move the cursor to the outside of those equations and I go comma x, comma y, so that we realise that we're solving for x and y. And I end up with x equaling 3 and y equaling 5, or alternately x equaling 5 and y equaling 3. So you can see either way dimensions 3 by 5 metres. I'll talk about solving quadratics using this technique of completing the square. So I've got a quadratic here, and I can't factorise this using PSF or the grid method. When you can't do that, you can factorise using a technique known as completing the square. This is what we do. We first of all list the first two terms, so x squared and 6x. I then take the coefficient of x, which is a 6, I halve it and square it. So I've got my 6 over 2, and then I take that answer and square it. So I add that to the first two terms. This positive 2 hasn't been lost, so I write that down. And keeping everything equal, if I'm adding that stuff in red, I need to subtract that same amount as well. Now, of course, 6 divided by 2 is 3. If I square that, it's 9. So I've now got x squared plus 6x plus 9. And I group that together. That leaves me with 2 taking away 9. So I've got x squared plus 6x plus 9, and then minus 7 equaling 0. The first three terms here that I've grouped are going to always be a perfect square. And with that, I'm able to factorise it. So I've got x squared plus 6x plus 9. The coefficient of x is a 6. So I can factorise that to become x plus 3 all squared. So it's always going to be just half the amount of what's in front of the x. So it's going to be the x plus half the amount that's in front of the x. So 3. Put that in brackets all squared. So I've got x plus 3 squared minus 7 equals 0. Solving for x, I can add 7 to both sides. I can now take the square root of both sides, remembering that I'll get both a positive and negative version for the square root of 7. Then subtract 3 from both sides. So I'll have the square root of 7 minus 3, or I'll have the negative square root of 7 take away 3. Let's look at an application, and this time, rather than writing the fractions within the equation, I'm going to use this little grid where C is the coefficient of x, H is just the amount halved, so I take that 4 and I halve it to get a 2, and then the S represents squaring, so I get the 2 and I square that and the answer is 4. So here's my quadratic trinomial. I list the first 2 terms. I then add to it half the coefficient of x squared, so as you can see here that's a 4. I haven't lost the negative 3, so I write that down. And if I'm adding 4, to keep everything equal, I need to also subtract 4. The first 3 terms I group together, and negative 3 take away 7 is negative 7. The first 3 terms will form a perfect square, so I can factorise that easily. So I write down the x, and I take half the coefficient of x and write that down inside the bracket, so it's just x plus 2 or squared, and that will always work. Minus 7, and now I add 7 to both sides. I take the square root of both sides, so it's going to leave me with x plus 2 equaling plus or minus the square root of 7. I now subtract 2 from both sides, and I write down my 2 solutions. C is the same story. First of all, I write it down so it's a quadratic on the left-hand side and 0 on the right. So it's x squared takes 7x plus 1 equaling 0. The coefficient of x is negative 7, so I write that down. If I halve it, it's negative 7 on 2. If I square that, it's positive 49 on 4. So I've got x squared minus 7x plus 49 on 4. That's the first part. Plus, I've got the 1 that I haven't lost, and then I'm also subtracting 49 on 4. The first 3 terms can be factorised to become x minus 7 on 2 squared, so that's just simply the x, and then I halve the coefficient of x, which is going to be negative 7 on 2, that's all squared, plus 1 over 49 on 4. In this line of working, you can see 1 can be written as 4 on 4. Tidying up these 2 fractions here, it's minus 45 on 4. And now I add 45 on 4 to both sides. And I take the square root of both sides. So x minus 7 on 2 is going to equal plus or minus the square root of 45 on 4. Now, with that, I can split up the fraction. So I can rewrite it. So it's a square root of 45 over the square root of 4. And with the square root of 45, I can rewrite it again as being the square root of 9 times the square root of 5. So 9 times 5, of course, is 45. So the square root of 9 times the square root of 5. The square root of 9 is just 3, so it becomes 3 root 5 all over 2, plus or minus. Fair bit in that. Now, x is going to equal that fraction here, plus 7 on 2. So I end up with 3 square root of 5 on 2 plus 7 on 2. They're both over 2, so I can rewrite it as being the square root of 3 multiplied by the square root of 5 plus 7, all on 2. And then the alternate solution is the negative 3 lots of the square root of 5 on 2 plus 7 on 2, which I can rewrite like so. And then finally give my answers like this. The only major difference here is that I've listed the positive term for 7. And I've listed the 7 here first. So a lot in that question. Question 5, we have ourselves an equation, quadratic equation. We need to solve for x using our calculator. So we've got, I'm just moving down again, menu, algebra solve, oops. And the quadratic is x squared plus 6x plus 2. So x to the power of 2 plus 6x plus 2 equaling 0. And I solve for x. And here are my 2 solutions. So these are my 2 solutions there. Again, remember to be sure that you are in exact mode. Of course, guys, what we could do is take that -1 and expand it through to get negative square root of 7, take away 3. That's another way of writing that out. So we've got the completing the square method, but we also had this idea of a quadratic formula, and this will work for any quadratic. So if it's in the format ax squared plus bx plus c, then x is going to equal minus the b plus or minus the square root of b squared minus 4 lots of a multiplied by c all over 2a. So in question A, we've got this quadratic equation. The a is 3, the b is 4, and the c is 1. We just plug them into the rule and keep working your way down, and we'll come up with solutions of -1 and -3. For b, a is -5, b is 1, c is 3. Again, we just plug in those values into the rule and we produce those two solutions. To satisfy a lighting requirement, a window that has an area of 2,000 centimetres squared. There's the window in terms of x's, and obviously this length here is 25 centimetres longer than its width. So the area is that, and we know that that must be equal to 2,000. And then for C, we need to solve the equation to find the value of x to the nearest centimetre. So clearly what we could do is solve that equation using our CAS and come up with the solutions. But let's just pretend we can't do that, and we're going to be using the quadratic formula. So I'm going to expand that x through. I'm going to form a quadratic equation on the right-hand side. I recognise that A is 1, B is 25, and C is -2,000. I substitute those into the quadratic formula. And now in each line here, I'm just tidying things up. So 25 squared, 625. 4 times -2,000, or -4 times -2,000, positive 8,000. So I have minus 25 plus or minus a square root of 8625 all over 2. This will simplify to that, and I can keep on going, and that there is my exact solution, plus or minus. And then to get the decimal approximate, just go Control Enter, and away you go. Please note, guys, that of course you're not going to be able to do such a complicated equation by hand. Like, these are big figures, obviously. So to get those figures, you had to use your calculator. But you should be able to be familiar with the technique and apply that technique to smaller numbers. So if we look at the quadratic formula, there's many parts to it, but what's really important is what goes on in the square root symbol. This is known as the discriminant, what I've got in red there, b squared minus 4ac. If we investigate the discriminant, it can tell us a lot about the number and type of solutions that are possible. If the discriminant, we use this delta symbol or a little triangle symbol, is less than 0, then there are no solutions, and that's reasonable. Remember that we can't take the square root of a negative number, so if we have what's inside the square root symbol as being negative, then obviously this whole expression will collapse and we'll have no solution. So that makes sense. If it's equal to 0, then what's going to happen is I'm going to have negative b plus or minus 0 all over 2a, so I'm really going to have negative b over 2a, so that'll be just one solution, it won't be two solutions. So looking at the discriminant is also important for the type of solutions that are possible. So if the discriminant is greater than 0 and it is a perfect square, then what we'll have there are two rational solutions. So because it's greater than 0, that means we're going to have two solutions, but because it's a perfect square, it means that the solutions are going to be rational. Okay, so a couple of things here. Rational just means that it doesn't have a square root symbol involved in the answer. So in its simplest format, it doesn't have a square root symbol. So the easiest way of thinking about a rational number is that in its simplest form, it can be written as a fraction. So as an example, the square root of 4 can be rewritten as 2, which can be written as 2 on 1, so therefore it's deemed to be rational. Now what's a perfect square? 1, 4, 9, 16, 25, 36, 49, 64, and so on. So those are our perfect squares. For question 8, determine the number and type of solutions for the following equations. So for A, we've got x squared minus 9x take 10, A is 1, B is negative 9, C is negative 10. So there's my discriminant, evaluate it, it's 121. 121 is a perfect square, because it's 11 squared. So we have two rational solutions. 121 is greater than 0, and it is a perfect square, so we've got two solutions. Furthermore, because it's a perfect square, it's rational. B, there's my equation. The discriminant evaluates to become 60. 60 is greater than 0, so we're going to have two solutions, but 60 is not a perfect square, so we have two irrational solutions. C, here's our quadratic. A is 1, B is negative 2, C is 14. Evaluate that, it produces negative 52. Negative 52 is less than 0, so there's no solutions for this. D, the discriminant equals 0, so because it's equal to 0, we have one solution. And if you got that one solution, in fact, it's always going to be a rational solution. Question 9. We've got ourselves a quadratic trinomial, and the coefficient of x is 2k, where k is an unknown number. For what values of k do we have two distinct solutions, one solution, and no solution? Alright, so let's look at the discriminant to begin with. So the discriminant is going to equal b squared minus 4ac. So you can see by plugging in those values, I end up with 4k squared minus 36. The easiest thing to understand here, to begin with, is where we have one solution. So I'm going to explain that to begin with. So there's b. Where is the discriminant equal to 0? So wherever it's equal to 0, then we're going to have one solution. So 4k squared minus 36 equals 0. Add 36 to both sides. Divide both sides by 4. Take the square root of both sides. So if k, an unknown number here, is either equal to negative 3 or positive 3, then that will mean that the discriminant of this equation will equal 0, and therefore there will be one and only one solution for x. All right, so we're not talking about the solutions for k, we're talking about the solutions for x. There will only be one solution for x. Let's now think about A. Where will we have two distinct solutions? So for two distinct solutions, we want the discriminant to be greater than 0. So I have 4k squared minus 36 being greater than 0, add 36 to both sides, and now we divide both sides by 4, and then we want to take the square root of both sides. So the square root will be either positive 3 or negative 3. Now, when we're thinking about k, we're only talking about the size of it. Okay, so I can write that k is greater than positive 3 or negative 3, but alternately, I could also say that 3 is less than positive k or negative k. It's just a different way of thinking about it. So if I go with this idea, then what I can say is that positive k is greater than 3, or I can say that negative k is greater than 3. Now, if I divide both sides by the negative, I'm going to end up with k being less than negative 3. So in order for us to have two distinct solutions here, then what needs to happen is that either k needs to be less than negative 3, so they're all very low values, or k needs to be greater than 3. So as an example, if k was equal to negative 5 and I threw in negative 5 in here, then my quadratic would be negative x squared minus 10x take away 9. That would produce two solutions for x satisfying this equation. And over here, if value for k, let's say it was positive 5, then my quadratic would be negative x squared plus 10x take away 9 equaling 0. Then that too would produce two solutions for x that satisfy the equation. Now finally C, what about no solution? So for that we want the discriminant to equal 0. Sorry, we want the discriminant to be less than 0. So working through that, I get the magnitude of k, so the size of k, ignoring its sign, needs to be less than 3. So plus k is less than 3, or negative k is less than 3. So again, working with the negative version here, if I divide both sides by negative 1, then I have k becoming greater than negative 3, noting that the inequality changes signs. So if I put k in the middle, then I have k being greater than negative 3, which is written there. And at the same time, k has got to be less than 3. So if we think about a number line now, and I haven't got anything written down, but I've got negative 3 here and positive 3. Those exact values will produce one and only one solution. Anything in between negative 3 and positive 3 will have no solution. Above positive 3 and below positive 3 will have two solutions. For this problem 9, I'll go over that in class and do another couple of examples because it's a very tough idea to try and understand.